Hi, my name is Hamzah Hussain and today I'll be going through a short presentation on the Asuro robot. So what is the Asuro robot and what does it do? The Asuro is a small robot which has been engineered by the German Aerospace Center. It is an autonomous vehicle using sensors to detect its surroundings to ensure correct decisions are made. The Asuro would read coordinates which has been programmed in C created by the user of the robot. So what is the structure of the robot? The structure of the robot is seen by the diagram which is shown on the presentation. So it's got a transceiver, which is the dongle which is with the package of the Asuro robot, is used to be able to send information to the devices via IR, which is the way of communication towards the robot. You got battery monitoring, which is the power supply to the Asuro, which is supplied by DC current. The back LEDs, which are components, detect the sides of which the Asuro is moving towards. Line following system uses the photo transistors to be able to detect light intensity. Tactile sensors are the switches in front of the robot, which can be programmed for different functions. Status LED will state what the robot is doing and how it's functioning. Engine allows the movement of the robot, and the odometer uses to calculate wheel rotation for the robot. The main aim for my robot was for it to be able to move on the line, as well as all the components fitted in the right places for it to be able to be a fully working robot. Here are more lists of what aims and objectives to which I have had to be able to build a robot. This is a simplified version of the method. So the Asuro robot will be made from the standard PCB board. You would need to heat up the soldering iron to 350 degrees, and to be able to follow the manual throughout, you start by placing both axles on the board and then solder them using the heated soldering iron. All this can be found on the Asuro manual, which is either based online or a copy which you can get with the Asuro robot. Also remember, the IC sockets will always be connected at the last, as it is the most fragile component there. Testing and evaluation was also done to be able to ensure that the robot was in a fully working order. Programming was also one part to ensure that the robot was able to work and move. Tests determined this, such as the LED test, the motor test, the odometer test, and the configuration test. The test which I found the hardest was the configuration test, as the numbers were very picky to choose from. Hence why I changed to the odometer test, which relies on the rotation of the wheel. So over here I will be going through the code which was used for the line test, which is shown in figure 1.2. This code was all based on the odometry test, so testing the wheel rotation of the robot. So on the left is the figure which shows the program, and underneath towards the right is commented out a version of what the program each does. So the motor direction, which is the movement of the wheels, so the engine would be moving forward. Here I will be talking about the line test, which the robot is in its final phase to when placed onto the lookalike monkey, which is also known as the line follower. This means that the robot needs to follow the line throughout its movements and positions. Here the robot would be using components such as the LEDs and mainly the photo transistor, which detects the light intensity. So if the robot was not following the line, the motor speed code, which has been previously shown in slide 7, would need to be adjusted in ratios for it to be able to finally work. It pushes away any untidiness on the floor in front of the robot. In further development, I had thought that I could make something a lot better, such as added an ultrasonic sensor to be on the front of the robot, which measures the distance for the robot to move on. So that is the end of my presentation. Thank you for listening.